Concrete is a big deal. It's a big deal in our lives, and it's a big deal for the climate. And we need it for all sorts of things. It's an incredibly utilitarian material, no question about that. We make 10 billion tons or so of concrete every year on Earth. Even though, pound for pound, concrete is a very low carbon material, you make that much of it, you're going to have an impact. If you add it all up and do the numbers, you get a cubic mile of concrete. A cubic mile every year, 5 times the height of the Eiffel Tower. If concrete were a country, the industry would be the 3rd largest emitter on Earth, after only China and the United States. And I know from being in it, being a structural engineer for decades, designing concrete structures and seeing how things work, we routinely make everything much stronger than it needs to be, which means higher carbon emissions than it needs to be. And most sidewalks in America, for example, are 3 times as strong as they need to be, because that's just what everybody did and nobody thought about it. We had all sorts of good reasons for doing that, but we don't need to do that anymore to get the quality concrete. We're not going to sacrifice strength and safety, but we can have it much, much lower carbon without even hardly trying. We've been making concrete for 10,000 years. The original concrete was clay concrete, what we call earthen architecture. You glue a bunch of little rocks together into a bigger rock. That's always been concrete, and it still is concrete. The original binder was clay, which worked great. It was available everywhere. It's really cheap, easy to work with, except it has this little flaw that it comes apart when it gets wet. Then the Romans came along, they improved on that a bit. They took their lime plasters and mixed them up with the volcanic soils they found around Mount Vesuvius, near Pozzuoli. That's where we got the name pozzolans. And they mixed that up, and they got this really cool concrete that would set up underwater, that would get strong no matter what happened, and would last forever. And it did last forever. So we have all these Roman structures from 2,000 years ago that are still there. The Pantheon, one of the most, to me, the most beautiful building in the world. And if you asked a modern structural engineering firm to design a Pantheon for you, they would give you something that wouldn't last 500 years, much less 2,000 years. Something to think about. But then 200 years ago, almost exactly 200 years ago, Joseph Aspdin in southern England patented Portland cement. It was based on Portland rock where he mined it. He figured out a way of cooking, baking the limestone, mixing in some clay and gypsum in ways that hadn't been done before. It was basically an extension of technology that was already in development, and he was the one who landed on the right formula at the right time. Talk about disruptive. It took over the world because it's a fabulous building product. You can screw it up in every way and it still gets strong. It's really cool, except for the emissions part. The biggest driver of decarbonization in concrete is human, talking to each other. Ask questions, listen to the answers, respect each other, basic human interaction stuff. Just by doing that and thinking through how can we get the project we want with the least amount of emissions. It doesn't need fancy new technology. It doesn't need any new technology. Sometimes less technology. So if you're buying construction services, ask. Ask for low carbon concrete, ask for low carbon everything, because there's all sorts of cool, new, zero carbon, and even carbon storing materials that are available to you. How do you make the change, right? What can you do? Depends on who you are. If you are a structural engineer, there's a few things you should know about, mainly that we need to break some bad habits. When I first came into the business almost 50 years ago, my boss would say, well, just with your concrete, make sure it's got at least 5 sacks of cement in there and maybe throw a little extra in and be sure. And so that's what I did. And I wrote these prescriptive specifications, and that's what we got. And the concrete supplier would probably throw in another sack himself. So we just everybody along the way just threw in a little more cement. For insurance, it was cheap insurance, and it made total sense. But my industry is still in the habit of just throwing in a little more cement all along the way. And this is maybe the biggest one for engineers. Don't write prescriptive specifications, write performance specifications. Don't say, get some butter and some milk and some flour and some chocolate and mix it up in a bowl and do this and in the oven and 400. Just say, I want a chocolate cake. Just give me a chocolate cake. But don't tell them how to do it, because you'll muck it up. You'll add cost and you'll add emissions to the whole business. And don't be moonstruck, which just means don't be hung up on the 28-day strength benchmark. That's another habit. We're used to specifying concrete strength at 28 days. Give it more time, you don't need as much cement, and that's where all the emissions are. Just by paying some attention and thinking about what we really need, how fast the concrete needs to come to strength, how strong it actually needs to be, how big a concrete member needs to be. If a 5-inch slab will work, don't give them a 6-inch slab. We just don't have to be so heavy-handed about it. The people who make concrete, I've developed a lot of respect for. I used to just tell you what to do. I'd write my specs as a young engineer and do this and do that and do that. It started to dawn on me eventually that you guys know a lot more than I do about concrete. There's trends at play here that are going to affect us both. You know, the old joke goes, there's two kinds of concrete, cracked and about to crack. Well, it's kind of the same way with concrete production all across the board. You're either monitoring your carbon emissions and reducing them, or you're about to, because you're going to have to, because that's the new rules of the game that are coming up everywhere. Local rules, state rules, federal rules. Who ever thought about carbon emissions? You're just making mud. You got some gravel, some sand, some cement, you deliver it, boom, done. We got to do a little better than that now. The main way is to look at the cement you buy. There's this thing called clinker factor. You probably know this, right? Clinker factor means how much of it is actually the clinker that they make in the kiln that's so super high carbon, the baked limestone ground up with some clay and gypsum, basic Portland cement. And a lot of people use pure clinker. More and more people are using clinker mixed with other things. Fillers like ground limestone, type IL cement, SCM, supplementary cementitious materials, fly ash and slag, and calcined clay. There's lots of things that you can mix in with the cement. All the SCMs that are out there in the marketplace right now are not just so that you don't use so much cement, though they have that effect. They make better concrete. They made the Hoover Dam during the Depression with a whole lot of fly ash because it reduced the heat of hydration. It didn't cook itself to death while it was curing out there in the desert. Here in the San Francisco Bay Area, we just rebuilt the Bay Bridge a few years ago, and Caltrans used a very high fly ash mix. Not because they were concerned about the climate, though they were aware and were concerned, but because it gave them better concrete. They're more resistant to the saltwater intrusion. So there's a lot of these solutions that build on each other that give you better quality concrete and reduce your emissions, all buried in the clinker factor, the type of cement you buy. Concrete, after all, is just a bunch of little rocks glued together into a big rock. That's it. That's our business, folks. That's concrete. That's how you make an adobe brick. That's how you make a sidewalk. That's how you make the Sydney Opera House. Question is, what kind of little rocks and what kind of glue? What we know is that if you got a really perfect particle gradation where there's no air in there, if you just poured all the little and medium and big bits into a bin and shook it around a little bit, there'd be hardly any air in there. Hardly anything for the cement to fill and have to do. You've all seen the pictures of those walls in Peru, of the Incas, right? These gigantic stones, and they're intricately fitted together. And I've seen walls like that in other parts of the world. And these are in seismically active areas where things get shook up once in a while, and yet these things are still there. No cement, no glue, they're just fitted together. That's the beauty of particle gradation. If everything's fitted together so well and so tightly fitted with each other, you got yourself a strong wall. You got strong concrete. And the cement doesn't have to do as much, so you don't need as much cement. But if you really took it to that extreme, you wouldn't be able to pour it or pump it or spray it. So that becomes a problem. Well, now it's less of a problem for two reasons. One, we have all these different particle sizes available to us, and we have admixtures that we can use, superplasticizers, ultra-high range water reducers, instead of water to give it flowability and workability. Because the more water you put in, the weaker the concrete. Everybody knows that. Particle gradation now is advancing to where we can do much, much better than we did in the past generations. Using better gradation, better plasticizers that are available to us now, and the need to reduce our emissions. It all adds up. It's part of the package. And again, you get better concrete out of the deal. Well, then there's the world of policy. The rules of the game. It affects us all. It affects the engineers, affects the concrete producers, and it affects the public. That's why governments write these rules. And the rules are changing. They're changing very fast. Nobody knew what embodied carbon was 5 years ago, and now that's what everybody's talking about. And there's a good reason. The embodied emissions of building materials are the great bulk of the climate impact of any building project. We thought it was about more insulation and better lights and all of that, which is all important. But the impact of all the concrete and the steel and the insulation and the glass that you use to build your project is far bigger climate impact than how well it operates over 60 or 100 years. And usually the way people start is to just require EPDs, environmental product declarations. It's just doing the math, it's doing the accounting, and ending up with the equivalent of a nutrition label on a can of food on the grocery store shelf. And it wouldn't be there if government had required product manufacturers to put it on there. Well, likewise, we're going to have EPDs for every kind of construction product. It's almost exactly the same concept, like a food label on a can of food. The first step is to require everybody to get the EPDs before you even set any limits. Say, no, we're not telling you you can't do this or can't do that. Just do the EPD and tell us what your carbon footprint is. The next step's going to be setting some limits. There's so many people out there making building products right now who have no idea what the impact of their work, their product is. It's time to change. There's a lot of cool tech coming. For one thing, everybody's already using crushed up concrete as their aggregate. We've worked out how to do that in a way that's effective. I had a concrete supplier tell me just the other day, that's all that they use in his company. Use AI, and there's new companies showing up using AI, or all along the process to help you get better gradation and better quality concrete with the least amount of emissions. There's new ways of making Portland cement. There are companies that are making aggregate literally out of emissions. They capture the emissions from the sky and turn those emissions into solid limestone. It's artificial limestone. And they make gravel and sand and all the things you need to put into concrete. And so you get carbon negative concrete, carbon storing concrete. Concrete industry is going to go from being a major emitter of emissions, 8% of global emissions, all the way to flipping that around and becoming a major absorber in the range of gigatons of carbon every year. So that every project you ever see in construction, you say, another win for the climate. There are many, many products at the level of making clinker or making cements and blended cements, at the level of making concrete, at the level of design and engineers not having to be so heavy-handed and designing more precisely because we have the means to do that. At every step, at every level of granularity in the industry, we can decarbonize a lot. The two most exciting things to me are making the concrete out of carbon in all the ways we do. Make the gravel out of carbon. Make artificial limestone out of emissions we took from the sky. The other one is biological concrete. People are making concrete with algae, with bacteria, with all sorts of microbes, without any added temperature or pressure, without any fossil fuels, without any funny chemicals involved. Biological concrete. There are companies making concrete with mushrooms, structural concrete. To me, this is the exciting thing. As an engineer, as part of the industry, as a father, soon enough, we're not even going to be worried about the emissions because we're just going to routinely be making concrete that absorbs emissions. Because it's just the obvious thing to do. And it's cool, and you'll be proud of every project you do. Not just because you're pouring good mud and you're designing a good building that looks nice and people can live in it and be happy. That's all great. That's what we do right now, and that's great. Now we can do it and also be doing a solid for the climate. You might be just somebody adding a bedroom to your house. You might be a developer building a high-rise building in San Francisco. You might be building a highway across Nebraska. No matter where you are, ask, be aware, challenge the habits of the industry. People often ask me, Bruce, why are you doing this? If you will, I can see generations down the road, the ones who aren't here yet. We can't even imagine yet. My great-grandchildren's great-grandchildren. I'm not leaving them a better world, I'm leaving them a worse world. So I think, what can I do about it? And I look around and I think, what can I do? And I do what I can. I put one foot in front of the other. I look for the highest lever I can grab and I pull on it. And that's what you can do too. Thanks for watching. We're BuildWell. We're here to make it easy to do climate-friendly buildings. Like us, follow us, and we'll see you down the road.